In this video, I want to do a quick review of some pre-calc topics and then kind of link them to some calculus topics. So I have three functions on the side here that I have written down. F of x is 2x minus 6 over x minus 3. G of x is 2x minus 5 over x minus 3. And h of x is x minus 3 to the 2/3. So, okay. So, first of all, let's actually do something with f of x here first. Hopefully you notice that the numerator can be factored into 2 times x minus 3. Okay. And that algebraically, we could divide by x minus 3 here. We're dividing, and we'll get f of x is equal to 2. There's one problem, though. We cannot divide by 0. And so the x value that makes the x minus 3 equal to 0 is equal to 3. So this division is legal if x is not 3. So what does that mean for the graph of this function? Well, if I were to graph f of x equals 2x minus 6 divided by x minus 3, what that means is I would see a line at y equals 2. Except at one point, and it might be hard to see on Desmos, but if I scroll over with my pen all the way over to 3, you'll see at 3 there's actually a secret little hole here. All right? So if I were to kind of graph this function on paper, I would actually graph f of x like this. I would graph f of x like this. I'd have x equals 3 here, and I would have nothing. So when do we get holes? Well, we get holes when a cancellation occurs. If we take a look, if I just modify the f of x to g of x here, if I just change this constant to from negative 6 to negative 5, I'm going to graph this function. I'm just going to change this to g of x. G of x, and it's going to be 2x minus 5 over x minus 3. Sorry, I'm having a little trouble here getting into there. There we go. X equals, okay, there we go. And all of a sudden, the hole is not there anymore, but what is there is a vertical asymptote. Hopefully you can see, as we get close to 3 now, we're actually getting really, really negative values from the left. And as we get closer to 3 from the right, we're getting really, really positive values. So this happens when there's no cancellation, because I can't really factor 2x minus 5. There's no cancellation. And I get a vertical asymptote. Notice this, I've not taken any derivatives or anything like that here. So right off the bat, I can determine if I have a hole or a vertical asymptote. Okay, now the next function. H of x is x minus 3 to the 2/3. I'm going to type that in. H of x is equal to x minus 3 to the 2/3. And hopefully we can see that at 3 there's some interesting behavior, but what's not happening is there's no hole and there's no vertical asymptote. Well, let's talk about why. So there's no hole because there's no cancellation. There's no cancellation. There's no dividing of a common factor. So that's why there's no hole. Is there a vertical asymptote? No, because there's no division. If I go ahead and evaluate h of 3, that's 3 minus 3 to the 2/3. That's 0 to the 2/3, and that's 0. I am not dividing by the x minus 3, where I am in the other examples. Now you might ask yourself, well, what is actually happening at this point? And the answer lies in taking the derivative. So if I go ahead and take the derivative of h of x, I'll need the chain rule a little bit. I have stuff to the 2/3, so that's 2/3 times stuff to the negative 1/3 times the derivative of the stuff. Derivative of x minus 3 is 1. And now if I look, I would turn this into a fraction because I have a 2 in the numerator and a 3 cube root of x minus 3 in the denominator. So now I get a division. Now I have a division. It's in the derivative h prime, and therefore the derivative h prime does not exist. So h prime of 3 does not exist. And that's why we get the sharp point at x equals 3. So we don't have a vertical asymptote, we don't have a hole, but we have a sharp corner. So hopefully you can start to see hole happens when you have a cancellation. Right off the bat, no derivatives. Vertical asymptote happens when you have division and there's no cancellation. And where you're getting a sharp corner or a cusp is when you have no cancellation, no division until you take a derivative. So hopefully these examples were illustrative of this concept. Thanks.